Good morning, students. Today we take the new chapter, States of Matter. So write down, everybody, States of Matter. You see, anything which occupies space, has weight and can be felt by your senses, known as matter. Matter is of three types: solid, liquid and gas. In your syllabus, we will discuss only the gaseous state of matter, not liquid and solid. That is only the gaseous phase is present in your class now. That is the part of your syllabus. So far as gaseous state of matter, that is highly compressible, low boiling point, highly flexible, boiling point is less than the room temperature, as well as intermolecular distance, interparticle distance is large. So they are highly compressible and highly flexible. In order to explain the properties of the gases, various laws are given. That is, the first law is known as Boyle's law. This law establishes the relation between volume and pressure at constant temperature. According to Boyle's law, now let us define the volume of the given mass of gas is inversely proportional to pressure at constant temperature. That means Boyle wanted to establish the relation between volume and pressure at constant temperature. So mathematically, Boyle's law can be expressed as it is as volume is inversely proportional to pressure at constant temperature. So volume is equal to proportionality change into K into 1 upon P, or PV equal to K. See, let me consider initial and final condition. Let P1, V1 are the initial and P2, V2 are the final pressure and volume respectively. So the way out of the four parameters, if three are given, then four can be calculated. So according to this law, P1 V1 equal to what is that? P2 V2, or V2 equal to P1 V1 upon P2, or P2 equal to P1 V1 upon what is that? V2. So the way you can have the Boyle's law. Graphically, this law is expressed as, see, the first graph I can plot it here, volume versus pressure. This is the volume and this is the pressure. Now volume is inversely proportional to the pressure. So the graph is like this, and PV remains constant. This side it is the pressure and this side it is the volume. So according to this, more the volume, lesser the pressure, and it's vice versa. So far as Charles law is concerned. According to this law, volume is, according to this law, volume is directly proportional to temperature at constant pressure. So mathematically Charles' law, it is written as volume is directly proportional to temperature at constant pressure. V is equal to K into T, or K is equal to V is equal to K into T, or K is equal to V by T. Let initial volume and temperature V1 and T1 and final volume and temperature V2 and T2. So according to this law, V1 upon T1 equal to V2 upon T2. Out of the 4 parameters, if 3 are given, then 4 can be calculated. The way you have explained the Charles law, the alternate form, the Charles law is, the alternate form of the Charles law can also be expressed as, so write down, alternate form of Charles law at constant pressure with every 1 degree Celsius rise or fall in temperature, the volume of the given mass of gas increases or decreases by 1 upon 273 of its initial volume. Let V0 is taken as initial volume. By you take the two conditions, by increasing the temperature, V at 1 degree Celsius is equal to V0 plus 1 upon 273 into V0. V at 2 degrees Celsius is equal to V0 plus 2 upon 273 into V0. Similarly, V at 3 degrees Celsius is equal to V0 plus 3 upon 273 of V0, and V at 4 degrees Celsius is equal to, V at 4 degrees Celsius is equal to V0 plus 4 upon 273 of V0, and V at T degrees Celsius is equal to V0 plus, or you can say 273 degrees Celsius is equal to V0 plus 2 upon 273 into V0. So the way at constant pressure, with every 1 degree rise or fall in temperature, the volume of the given mass of the gas increases or decreases by 1 upon 273 of its initial volume. So this condition I have taken by increasing the temperature. Now by decreasing the temperature, just to put down, by by decreasing the temperature, V minus 1 degree Celsius is equal to V0 minus 1 upon 273 V0. V minus 2 degree Celsius is equal to V0 minus 2 upon 273 V0. V minus 3 degree Celsius is equal to minus 3 upon 273 V0. V minus 273 degrees Celsius is equal to V minus 273 upon 273 V0. This is the cancelled out. So volume minus 273 degrees Celsius is equal to what is that? 0. So what is your conclusion? The temperature at which, that is what it is, the volume that is at minus 273 degrees Celsius is what actually? This is the 0. So we can define as, it can be defined as the temperature at which volume of the gas, the temperature at which volume of the gas becomes 0 is called absolute temperature minus 273 degrees Celsius or 0 Kelvin. This is the Charles law. Graphically, this law is expressed as, it is the volume V0 100, 200 as well as 300 degrees Celsius, 100 degrees Celsius, 200 degrees Celsius or 300 degrees Celsius. This side write by increasing the temperature, and this side you write by decreasing the, what is that, temperature. This is what actually minus 100 degrees Celsius, minus 200 or minus 300 degree Celsius. What is that? 273 lies in between 200 and what 100? 300. Extrapolation of the graph, and then volume is going to increase. So that is what it is, the extrapolation of the graph, where the volume does not exist, and then you can see what is that, more the temperature, more the volume, and minus 273 degrees Celsius, this is what it is, the minus 273 degrees Celsius or 0 Kelvin is called as absolute temperature, that is the 0 Kelvin. So this is, Charles law. Now next is the what law? Avogadro law. So write down everybody, what is Avogadro's law? According to this law, at constant temperature and pressure, the volume of the given mass of the gas is directly proportional to number of moles. Mathematically, volume is directly proportional to the number of moles at constant pressure and what? Temperature. So volume is equal to A into N, where A is Avogadro's constant. A is equal to V by N. Let initial and final conditions. Let V1 upon N1 equal to V2 upon N2. If N1 equal to N2, then V1 upon N1 equal to V2 upon N1. N1 N1 cancel. So it is the V1 equal to, what is that? V2. That means for different moles of the gas, volume of the gas remains constant. Hence Avogadro law can also be concluded as for different moles of the gas, the volume of the gas remains constant. This is the Avogadro law.